Hello everybody, this is my new video and this video is about EtherChannel and this is part number 1. In part number 1 I'm gonna speak about dynamic link aggregation protocols, LACP and PAgP port modes, EtherChannel configuration, PAgP silent and non-silent operations, EtherChannel configuration rule and requirements, PortChannel status verification, logical interface EtherChannel statuses, EtherChannel member statuses, and verifying EtherChannel neighbors and packets. So let's get started. Ethernet network speeds are based on powers of 10 megabits per second, 100 megabits per second, etc. How can we increase the bandwidth? Ideally, it would be great to just plug one more cable, but then a spanning tree will block one of the ports to prevent forwarding loops. The best solution in this case is EtherChannel bundle, which aggregates physical links into a logical link and allows load balancing of traffic among the physical links in the EtherChannel, as well as redundancy in the event that one link fails or more links fail in the EtherChannel. STP will treat aggregated links as one link as it operates on logical links but not on physical links. Each port in EtherChannel must be configured compatible. They all should be also configured as layer 2 trunk or access or layer 3 routed ports. Using EtherChannels helps to reduce topology changes in case a member link goes down or up. If a link status change happens, it will not trigger layer 2 STP3 calculation or layer 3 route calculation. EtherChannel can be formed statically by setting on state or by using a dynamic link aggregation protocol, which is more preferable as it provides a way to ensure end-to-end connectivity between devices across all network links. Dynamic link aggregation protocol would detect physical link degradation and the respective interface would be made inactive for EtherChannel. That would make traffic not load balanced through degraded link and would avoid packet loss. When EtherChannel is formed statically, there is no health integrity check, and if the physical link degrades and keeps the line protocol in an up state, the PortChannel will reflect that link as available for data transfer, which may not be accurate and would result in occasional packet loss. There are two common dynamic link aggregation protocols: Link Aggregation Control Protocol LACP and Port Aggregation Protocol PAgP. LACP is an IEEE standard defined in 802.3ad and was created as an open industry standard. LACP lets devices send Link Aggregation Control Protocol data units (LACPDUs) to each other to establish a link aggregation connection. PAgP is a Cisco's proprietary protocol that can be run only on Cisco switches and on those switches licensed by vendors to support PAgP. There are two modes in LACP. First one is active, which places a port into an active negotiating state. The port starts negotiations with other ports by sending LACP packets. The second one is passive, which places a port into a passive negotiating state. The port does not start LACP packet negotiation, but responds to LACP packets that it receives. LACP sends messages to the multicast MAC address 0180C2000002. And for example, if we have active mode on one end of the link and active mode on the other end of the link, LACP will form adjacency. If we have active mode on one end of the link and the passive mode on the other end of the link, LACP will form adjacency. And it will form adjacency as well if we have passive active. But if we have passive mode on one end of the link and passive mode on the other end of the link, LACP will not form adjacency. There are two modes in PAgP. First one is auto, which places port into a passive negotiation state where port does not start PAgP packet negotiation, but responds to PAgP packet it receives. The second one is desirable, which places port into an active negotiation state where port starts negotiation with other ports by sending PAgP packets. PAgP sends messages to the multicast MAC address 0100-0CCC and the protocol code 0104. If we have auto mode configured on one end of the link and auto mode configured on the other end of the link, PAgP will not form adjacency. If we have auto on one end of the link and a desirable mode configured on the other end of the link, PAgP will form adjacency. And vice versa, if we have desirable on one end of the link and auto on the other end of the link, PAgP will form adjacency. If we have desirable on one end of the link and desirable on the other end of the link, PAgP will form adjacency. EtherChannel can be configured in the interface configuration mode for the member interfaces by assigning them to the EtherChannel ID and configuring the corresponding mode. For static EtherChannel, use the command channel group and then we have channel group ID mode on. For LACP EtherChannel, use the command channel group ID mode, and then we have two options, active or passive. And for PAgP EtherChannel, use the command channel group ID mode, and then we have two options, auto or desirable. Channel group ID is the ID of your channel which you want to create. When a PAgP mode is configured as auto or desirable on the port, there is also operational parameters can be configured. First one is silent. The EtherChannel bundle is formed even if data has not been received from the remote device. It allows to establish an EtherChannel with a device that is not PAgP capable, for example, server. Silent is the default operational mode for PAgP. And the second one is non-silent. The EtherChannel bundle does not form until the bidirectional connectivity has been confirmed. In other words, non-silent requires a port to receive PAgP packets before adding it to the EtherChannel. Recommended when connecting PAgP compliant switches. There are few configuration rules which is good to follow while configuring EtherChannel. First rule: all the channel group commands for all the physical interfaces for specific EtherChannel on the local switch must use the same channel group number. Second rule: the channel group number may be different on the neighboring switches. Third rule: if using on keyword, it must be used on the corresponding interfaces on both switches. Fourth rule: if using the desirable keyword for PAgP on one switch, the other switch must use either desirable or auto. Fifth rule: if you use the active keyword for LACP on one switch, the other switch must use either active or passive. Sixth rule: all member interfaces must be active. And the seventh one: all member interfaces must be consistently configured except for LACP port priority. There are few configuration requirements for EtherChannel. First one is port type. All ports participating in PortChannel must be consistently configured to be a layer 2 switch port or a layer 3 routed port with no switch port configuration on the interface. Second one, port mode. All layer 2 physical ports must be configured as either access ports or trunking ports. All must be access or all must be trunk. Next one is speed. All member interfaces must be the same speed. Next one is duplex. The duplex mode must be the same for all member interfaces. Next one is access VLAN. All member interfaces configured as access ports must have the same access VLAN configured. This is for layer 2. Allowed VLANs. The member interface trunk ports layer 2 must be configured with the same list of allowed VLANs. Native VLAN. Native VLAN must be the same on the member interface trunk ports. This is for layer 2. STP interface settings must match on all physical interfaces. This is also for layer 2. MTU. MTU has to match on all physical interfaces. The physical interface cannot be added to the port channel if the MTU on the interface does not match the MTU of the other physical interface. Load interval. Load interval must be configured the same on all member interfaces. And storm control. Storm control must be configured the same on all member interfaces. These two options, load interval and storm control, these configuration requirements I found in the book, but I was not able to check them in the Cisco viral environment. So if you have hardware and you can check it, please check and let me know in the comments to the video. To show an overview of all the configured Ether channels along with the status and dynamic aggregation protocols for each one, use the command show EtherChannel summary. In the result of this command, you can find the following important information: group, the group number of each Ether channel or port channel, the name of port channel, for example, port channel 13, with flags SU. S means layer 2 and U means in use. And then you can find the protocols for each port channel. Then you can find also physical interfaces bundled in each port channel and status for each one. P means bundled in port channel. If you see flags SU and P, it means your port channel is working and everything is fine. To view information about the logical interface, use the command show interface port channel and then port channel ID. So let's review what each logical interface EtherChannel status means. D means down, the EtherChannel interface is down. U in use, the EtherChannel interface is working properly. S layer 2, the EtherChannel interface is configured for layer 2. R layer 3, the EtherChannel interface is configured for layer 3. M not in use, minimum links not met. Traffic will not be forwarded across this port channel interface because even though the EtherChannel has established at least one LACP adjacency, but it is configured with a minimum number of active interfaces that exceeds the number of active participating member interfaces. Let's review statuses of EtherChannel members. P bundled in port channel. The interface is actively participating and forwarding traffic in port channel. P hot standby for LACP only. There is configuration with the maximum number of active interfaces on the port channel. This interface is acting as hot standby and does not forward traffic even though it is participating in LACP with the remote peer. I stand alone. The interface is treated as an individual as it has not detected any LACP activity. Small letter W, waiting to be aggregated, waiting for a packet from the neighbor to make sure it is still alive. Small s, suspended. The member interface is in suspended state. And very important note, the status of flags are case sensitive, so be careful. How to verify EtherChannel neighbors? The following command displays detailed information from the local configuration and information from the LACP and PAgP packets. Show EtherChannel port. The following command displays information about LACP neighbor, including the neighbor's system ID, system priority, and whether it is using fast or slow LACP packet intervals. Show LACP neighbor, and there is optional keyword detail. Here you can find the output of show LACP neighbor command. You can find ports of the partners or neighbor. You can find flag, which means S for devices requesting slow LACP use and P device is in passive mode. You can find also LACP port priority and device ID of the neighbor. To check the local LACP system ID, use the command show LACP sysid. To display additional information about PAgP neighbor, including neighbor system ID, remote port number, and whether it is using fast or slow PAgP packet interval, use the command show PAgP neighbor. Here you can find example of the output of this command show PAgP neighbor. Here you can find ports on the local switch, name of the remote neighbor switch, device ID or system ID of the remote switch or neighbor switch, ports of the neighbor switch, and flags. S means device is sending slow hello, and C, device is in consistent state. One of the important steps in troubleshooting the establishment of the port channels is to verify that PAgP or LACP packets are being transmitted between devices. And the best way to do such troubleshooting step is to check PAgP or LACP counters with the commands show PAgP counters for PAgP protocol or show LACP counters for LACP protocol. Here we have example of output from these both commands. Show PAgP counters, and you can see information sent, received, and show LACP counters. LACP DUs sent and received. To clear counters, use the command clear PAgP counters for PAgP protocol or clear LACP counters for LACP protocol. Let's configure layer 2 Ether channels. So in this topology, I'm gonna bundle links between SW2 and SW1 switches into LACP port channel, and ports on SW1 switch facing SW2 switch I'm gonna configure in active mode, and ports on SW2 facing SW1 switch I'm gonna configure in mode passive. These links between SW3 and SW1 switch I'm gonna bundle into PAgP port channel, and the links or interfaces on SW1 switch facing SW3 I'm gonna configure in mode desirable, and interface on SW3 switch facing SW1 switch I'm gonna configure in mode auto. And these links between SW2 and SW3 switches I'm gonna bundle into port channel statically. So let's go and do configuration. Switch SW1 conf T, we have interfaces G02 and G12. Interface G02, channel group 12 mode active, interface G12, channel group 12 mode active, and interface G03 and G13 facing SW3 switch. G03 channel group 13 mode desirable, and interface G13 channel group 13 mode desirable. SW1 switch is configured. Let's go to SW2 conf T, interface G01 channel group 21 mode passive, interface G11 channel group 21 mode passive, interface G03 facing SW3 channel group 23 mode on, interface G13 channel group 23 mode on. Let's go to the last switch, SW3 conf T, interface G01 facing SW1 channel group 31 mode auto, interface G11 channel group 31 mode auto, interface G02 channel group 32 mode on, interface G12 channel group 32 mode on. So everything is configured, and now let's do verification. First verification command is show EtherChannel summary. From the output of this command you can see we still have problem with G11 interface, and this is interface facing SW1 switch. Let's go to SW1 and see what is happening. G011, it's connected to G13. Let's go. Show run interface G13 channel group on 3 mode desirable. Show EtherChannel summary. We can see that on this side everything is fine. Let's double check on this one. Everything is fine, just probably has not received in packet PAgP packet at that time. So from this output we can see that we have two port channels, 31 and 32, with flags SU. S means layer 2, U means in use, everything is fine. Protocol PAgP second one is static, ports G01, G11, G02, G12, and P means bundled in port channel. So these flags SU and P for layer 2 EtherChannel means that port channel is working fine and there is no problem. Let's go and check on switch SW2 summary. Same, everything is fine, just we have different protocol LACP and SW1 switch. As you've seen, we have SU and we have two protocols LACP, PAgP. All interfaces, member interfaces are fine, so everything is good. Let's check next command, show interfaces port channel and 1, 2, and this is the same like we have show interfaces for a physical interface on the switch. The same command, you can see the same output. Protocol line protocol is up, port is up, MTU configured and the interface bandwidth, encapsulation, packets received sent, useful information. Next command is show EtherChannel port. This command has a lot of information in the output, but it is very useful. For example, you can see that it shows in output each port channel configured and ports in this port channel. Port channel name, mode configured on this port, on this switch, protocol configured LACP, and local port G02, for example, has flags SA, device is sending slow LACP dues, A mean device is in active mode, port priority, and some port number, port information, and we also have partners information, so information from the neighboring switch connected to the link on this port G02, and neighboring port on this link has flag SP, means device is sending slow LACP dues and it is configured in passive mode. Port priority as well, device ID, interval between since last packet sent, and also in time has this interface has been bundled into port channel. And then you can see next port and information, and also next port channel, the second one G13, and this one is PA protocol PAgP configured interface. G03 on this switch is in desirable mode. Flags SC, device is sending slow hello, and C, device is in consistent state. You have hello interval default, and you have also partner information on this local port G02. You can see that there is switch SW3, which is partner switch, device ID, partner port, remote port, and timer for packets. And you can also find partner flag SAC. It means that it's configured device is sending slow hello, and auto mode. Remember, I configured SW3 in auto mode, and device is in consistent state. And also time, this interface has been bundled in the port channel. Okay, so let's go to next verification, and this command has a lot of information in the output, but there is also command to verify neighbors and adjacencies for each protocol, and it has less output. So LACP neighbor. You can see local ports on this switch, flag on remote on neighboring switch, and port priority, device ID, age between packets. And this command also have for LACP, it has a detail keyword which gives you more information. System ID, system ID, port priority, status, or configure it in passive remote port. So this is for this information, this command, verification command. And for PAgP, the same command. Show PAgP neighbor. Also, but it shows local ports, but partner name on the remote switch, which is SW3, device ID, partner ports on the remote switch, information, and timers and partner flags. Means device in sending slow hellos, devices in auto mode. Remember, I configured SW3 in auto mode, and C, devices in consistent state. Next verification command is for LACP system ID. You can find system ID for LACP protocol configured on this switch. And for example, show LACP system ID for SW2. And next, the last one, the last command which I wanted to show you for verification is show LACP counters. This command is very useful when you want to check if your switches are sending and receiving packets in LACP or PAgP protocols. Just the neighbor switches, they exchanging information. You can see that G02 interface sent 31 LACPDUs and received 26 LACPDUs. The same information for G12, and the same command for PAgP protocol, so PAgP counters. You can see on interface which has sent 35 packets and received 24. And also you can reset these counters, LACP counters, and clear PAgP counters. So let's verify. Show LACP. Now I reset these counters, and PAgP show PAgP counters 0. So this is everything that I wanted to show you about layer 2 EtherChannel configuration and verification. Let's configure layer 3 EtherChannels. So I'm gonna use this topology and bundle these two links between these two switches into PortChannel. So let's get started. Switch SW1 conf T interface PortChannel, and this is gonna be 1.2 no switch port, and IP address 192.168.0.1 255.255.255.252. Interface range G012 no switch port, channel group 1.2 mode active. Show IP interface brief.
Okay, and let's go to SW2 switch. Interface port channel to 1. No switch port. IP address 192.168.0.2.255.255.255.252. Interface range G012. No switch port. Channel group to 1. Mode active. Okay, let's see. Show other channel summary. And we can see that our port channel is up and running. And the difference between from this layer 3 and layer 2 other channel in Flux, you can see RU. R means layer 3, U means in use, and ports are still the same, P. Let's go to switches W1, show other channel summary. Same here, RU, PP. Port protocol LACP. Show port channel. Show other channel port, and it is the same like for layer 2. You can see that interface, this is our port channel 1, 2, this is first interface in this port channel, and it's inactive. LACP Flux SA, the slow LACP use active, and information about partner switch. Okay, and show LACP neighbors. And for neighbors, you can see the same information. Flux of the neighbor S device is requesting slow LACP use, and A active. It was configured with active option. Okay, now just let's change from LACP to PAgP. Conf T interface range channel group. Interface range G012 channel group 1.2 mode desirable. We need to remove it. No channel group. We need to remove LACP first. Channel group 1.2 mode active, and then we're gonna configure to desirable. And let's go to, and as you can see, show other channel summary. It changed to down. It's still layer 3, but now it's in down state, and ports are suspended. Suspended status. Let's go to second switch. Conf T interface range G012. No channel group 2.1 mode active. Channel group 2.1 mode, let's say auto. And now we're gonna see our other channel. Show other channel summary. It's still waiting and suspended, and now it's gonna change to up. Interface port channel change to up. Let's check. Yes, RU PP and this one. It changed from suspended to bundled in PortChannel. So let's do show EtherChannel port. On this you can see again PortChannel, first interface, mode desirable, and the protocol PAgP, local port information SC, device is sending slow hello, device is in consistent state, and partners information status SAC, which means the device is in auto mode. As you remember, I configured it SW2 switch in auto mode. Let's see, show PAgP neighbors, and again you can see that device is in auto mode, device sending slow hellos, and device is in consistent state, timer, remote ports G01, local ports, and a name of a neighboring switch with device ID. That's all what I wanted to show about layer 3 EtherChannel configuration. Here you can find some very useful links with information that I've used during preparation and studying. At this point I would like to say thank you for watching my video. I hope you liked it. Please don't forget to subscribe to my channel. I wish you success in your studying and I hope to see you soon. Ciao ciao!